Hello and welcome to Lesson 9a. I can relate the equation of a circle to its graph. So we're going to talk about circles in Unit 9, and the first thing we're learning to do with circles is how to graph them. And a circle is defined as the set of all points in a plane that's a fixed distance, or the radius, away from a point called the center. And two circles are considered congruent if and only if they have radii with equal lengths. So when I look at a circle in the coordinate plane, the radius extends from 0, 0 out to the edge of the circle, and it's a fixed width, and it always produces points x, comma, y. Now, if we were to look at this as a triangle, where this is x and this is y, and that's my radius r, if you notice, that makes a right triangle, which means you can actually describe the equation of a circle in terms of the Pythagorean theorem. So where x squared plus y squared is equal to the radius squared. Now this is true if we're centered at 0, 0. So if we were to, for example, move our circle to a new center, h comma k, the distances here change. This is now the difference between x and h, or x minus h, and this is the difference between y and k, or y minus k. So my equation with a circle centered at h comma k is now x minus h squared plus y minus k squared equals r squared. That's how we find that's our standard form for the equation of a circle. So guys, if you remember one thing today, this is it. I want you to put a big old star next to it, circle it, bubble it. This is the big idea today, okay? Remember that guy. So how exactly do we then write the equation of a circle? Well, the first thing we do is we identify the center and the radius. So I would then replace the h and the k in my equation, my standard form of the equation, with the values from the center, which is in and of itself h and k, and I'd replace the r squared with the square of the length of the radius. So let's look at an example. Here I have a circle and I want to find the center. So what I'm going to do is I'm going to draw two diameters, and I can tell that they're diameters if they go from the absolute edges of the circle. And I notice that my diameters are crossing right here at 0, negative 3. So my center is at 0, negative 3. It's a 0. And my radius, I can actually just count out my radius to find it. My radius is, I count 1, 2, 3, 4, 5 units. My radius is 5. So when I plug in to x minus h squared plus y minus k squared equals r squared, this point up here is my h and my k. So I would do x minus, my h value was 0 squared, plus I'm going to do y minus, my y value was negative 3 squared equals, my radius was 5 squared. And then my last step is just simply to simplify that. X minus 0 is just x, so I get x squared plus y minus a negative 3 becomes y plus 3 squared, which equals, and 5 squared is 25. So that is the equation of the circle. So we can do this without a graph as well, where they simply give me the center. My center is at negative 9, 6, and a radius of 8. I simply plug in. I do x minus, my x value here was negative 9 squared, plus y minus, my y value is 6 squared equals my radius squared, and we simplify. Minus a negative becomes x plus 9 squared plus y minus 6 squared equals 64. And we can do the next one. If I have a circle centered at 0, negative 7 with a radius of root 23, I simply plug in x minus 0 squared plus y minus a negative 7 squared equals root 23 squared, or this just becomes x squared plus y minus a negative 7 is just y plus 7 squared equals, and the square root of 23 squared is just plain old 23. So that's my equation. Now, we can make this problem just a little bit harder. In this next one, I'm given a diameter of my circle and the endpoints of that diameter. And I want to find the equation of the circle with that diameter. Well, the center will always end up being the midpoint of any diameter. So if I want to find the center, I'm simply going to use my midpoint equation. If you guys remember, it's been a while, but if you guys remember, our midpoint equation is my xm, ym, because remember the midpoint is a point, is equal to the average of my x's and the average of my y's. That is a y1, by the way. So when I plug in, I would do 1 plus 7 over 2, comma, negative 8 plus negative 2 over 2. The average of my two x values, 1 and 7, and the average of my y values. And when I do that, 1 plus 7 is 8 divided by 2, gets me an x value of 4. And negative 8 plus negative 2 gets me negative 10 divided by 2 is negative 5. So my center of my circle is at that midpoint for negative 5. Now, the radius of my circle is the distance between the center and any point on the circle, including, guys, the endpoints of the diameter. So to find the radius of the circle, I'm going to find the distance between my center point and one of my two endpoints. I'm going to choose, so I really want to find the distance between my center, which in this case is 4, negative 5, and an endpoint, which I'm just going to randomly choose 1, negative 8. You could use either one. They'll both get you the same answer. And for distance, we're going to use the distance formula. So I do distance equals the square root of, it's x2 minus x1 whole quantity squared plus difference of the y's, y2 minus y1 whole quantity squared. So I plug in square root of difference of my x's, 4 minus 1 squared, plus difference of my y's, negative 5 minus negative 8 whole quantity squared, which gets me the square root of, that's 3 squared plus 3 squared, or root 18. This simplifies, it's 9 times 2, so it's really 3 square root 2 is my radius. And now I've got a center point, I've got a radius, I can plug in to find the equation of my circle. So if I'm doing basic equation of my circle is x minus h squared plus y minus k squared equals r squared. I plug straight in. I do x minus, the x value of my center was 4 squared, plus y minus, the y value of my center was negative 5 squared equals, and my r was 3 root 2, and I'll have to square that as well. And my last step is just to simplify. The x minus 4 does not change, and y minus a negative 5 becomes y plus 5 equals, and when I do this, this distributes to both, so this becomes 9 times 2, which is 18. And this right here would be the equation of the circle with that diameter. All right, and then the last thing we get to do in this lesson is to actually graph circles. So we've talked about now how to get the equation of a circle. Let's talk about how you actually graph it. It starts the exact same way as before. You're going to identify the center, and in this case, it's the opposite sign of whatever's attached to the x and the y. If I have x minus 2, my x value is at 2, and if I have y plus 3, my y value is at negative 3. And my radius is the square root of whatever this number is, which in this case is 4. So I'm first going to plot my center. We're at 2, negative 3. So there's my center. And then I'm going to put 4 points that are the radius away from that in all 4 directions. So I'm going to go 4 out to the right. I'm going to go 4 up, 4 to the left, and 4 down. And if you have a compass, you can use a compass to get a perfect circle. If not, you can freehand as best you can, just like that. And that's my circle. So that's all you do. This next one, my center here is going to be at opposite of the x would be -3. Opposite of y minus 5 would be at 5. And my radius is the square root of whatever that number is, and square root of 1 is 1. So I go to -3, 1, 2, 3, 4, 5. That's my center, and I go out 1 in all 4 directions. 1, 2, 3, and 4 directions. And then we just connect those 4 points. That was bad. I'm sorry, guys. Let me try that again, shall I? Let's connect those 4 points slightly better than before. That's a little bit better. And that's my circle. So let's do another one. Here, real quick, guys, in MML, not in MML, in Edpuzzle, I want you to take a minute and tell me what is the center of this circle. So what is the center? All right, so you should have gotten that the center is at -1, 0. And your radius is the square root of 25, which is just 5. So you're going to plot -1, 0. And we're going to go out 5 in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 5 down. And we simply connect those 4 points to make our circle. All right, let's look at this last one. My center, notice there's no value attached to the x, so it's just at 0, whereas we do the opposite of that 1 there, which is +1 for y. And my radius is the square root of 37. Now, that's not a perfect square. If you are interested in honors, I want you guys to look at the honors problem set. Specifically, I want you to look at the first 3 questions in the honors problem set right now, because this is going to talk about how you can sometimes graph the radius when it's not a perfect square. But as that's an honor specific problem, we're going to assume that the square root of 37 is just a little bit bigger than the square root of 36, which is 6. So it's a little bit larger than 6, which for the purpose of us graphing by hand is all we need to know. So if we're at a center of 0, 1, I'm right here, and I'm going to go out a little bit more than 6 in all directions. 1, 2, 3, 4, 5, 6, and a little bit. 1, 2, 3, 4, 5, 6, and a little bit more. 1, 2, 3, 4, 5, 6, and a little bit. 1, 2, 3, 4, 5, 6, and a little bit. And then we join up those 4 points as best we can. And that's all you got to do. All right, guys, thank you very much for watching the video. Take a look at the MML practice and y'all are good to go. Thank you.